What's up, guys? We're gonna find some angle measures and side lengths using either sine, cosine, tangent, cosecant, secant, and cotangent. So first thing I have on here is something that we filled out in class is we took two special right triangles, so a 30, 60, 90 and a 45, 45, 90, which 30, 60, 90 has a side of 1, square root of 3, and a hypotenuse of 2. A 45, 45, 90 has side lengths of 1 and a hypotenuse of square root of 2. And what we did in class is we filled in this table, which has all 6 trig functions for a 30-degree angle, for a 45-degree angle, and a 60-degree angle. And not only did we figure out all 6, but some of these we simplified or we rationalized the denominator, whatever we needed to do. So this is the final answers that we arrived at for this table. So now what we're going to do is we're going to be able to use this to answer a few questions as well. So the first problem I want to start with is find the value of x for the right triangle. So I have a right triangle here. Looks like we got this angle measure B down here is 30 degrees. We got a side length of 9, another side length of x. Now, since we are focusing on trigonometry, and trigonometry is all centered around the angles, the first thing I do is kind of pick out what in the world do we even have. So we're going to focus everything around this 30 degrees. So things I'm going to point out is, well, this opposite side, that would be the opposite. So I'm going to label that as OPP. The side of 9 would be my adjacent. And just to fill it in, this long length here, that is the hypotenuse of this triangle. So we're given an angle measure. We would like to know the opposite side while we were given the adjacent side. So things I would think about is, well, what show the 6 trig functions uses an opposite and an adjacent. An opposite and an adjacent. And what's going to use that, if you've watched some of my earlier videos on trigonometry, is that is going to be the tangent function. So if I take tangent of this angle, I should get opposite over adjacent, or x divided by 9. Now we're going to take a non-calculator based approach on this on how to solve for x, because I want an exact value. And I'm going to show you here in a little bit why calculator might be a little bit easier, but it's also not always precise, depending on what one student is doing from another. So the reason why we have this table up here is we found out earlier what the tangent of 30 degrees was. So here's 30 degrees, and we found using these triangles that the tangent of 30 degrees is the square root of 3 divided by 3. So what I'm going to do is I'm going to go down here, and instead of writing tangent of 30, we're going to replace it or substitute it with square root of 3 divided by 3 equals x divided by 9. Now the reason I'm doing that is it allows us to use a lot more specific answer instead of a decimal form, and we could actually solve this here from x. So if I want to solve for x, that means we got to get it alone. Right now we are dividing by 9 with the x, so to get rid of a division by 9, we are going to multiply the right side by 9, which means we got to multiply the left side by 9. That means those 9's are gone, and on the left side we're left with x equals, this 9 is going to be on top, the numerator, 9 square root of 3 over 3. Now before I'm done, I do want to look and see, can I do anything to simplify this fraction, which we can. If you cover up that irrational square root of 3, you'll see we have 9 divided by 3, which, as we should know, 9 divided by 3 is 3. So that simplifies to a 3 on the outside and a square root of 3. So x equals 3 square root of 3. And that is an exact answer. So every single student that does this without a calculator, all of us will arrive with this specific answer as long as we all do it correct. So now let me show you a little bit of a calculator-based approach. And we're going to make this problem a little bit more difficult. We're going to solve the triangle A, B, and C. So I have triangle A, B, C. I have a few pieces filled in, but we're going to solve the triangle. Now what that means is you need to identify all angle measures that aren't already known, and you need to find all side lengths that aren't already known. So for my angles, I do not know angle A, I do not know angle C, and I do not know side A, and I do not know side C. So we're going to find all four of those. Now, there are a few pieces here that do come easily and some that are going to require a little bit of work. So what we have here is when you have this square here, you should remember from geometry, what that means is that this is a 90-degree angle. So I could fill in angle C is 90 degrees. That was easy enough. Now, to find angle A, you're going to have to remember one of our properties of triangles back in geometry. And what that was is all three angles of a triangle should add up to 180 degrees. So if I take 180 degrees and I subtract off these two angles, all that should be left would be our last angle up here. So I'm going to subtract 90, and I'm also going to subtract 37, which is our known angle over here. So if you take 180 minus 90 minus 37, you will get 53 degrees. And what that was angle A. So I found two of the four pieces I need. I just need to find the remaining two. Now, to do that, we're going to do something very similar to the front side. So what I like to do is, even though I figured out angle A and angle C, everything I'm going to do is going to revolve around what pieces were given to us at the very beginning. So we were given this angle is 37 and this side length is 11. The reason why I like to stick to those is, what if we made a mistake on these two numbers? Well, if I made a mistake on these two numbers and then use those wrong numbers to calculate A and C, I'm going to use an incorrect answer to create even more incorrect answers. So I like to stick with what do we know for sure is true, just in case I made a mistake. Now, we did not make a mistake here, but just to make sure I don't make a mistake. So I'm going to use this 37 degrees and this side of 11. So what I'm going to do is I'm going to label, in reference to this 37-degree angle, what do I have? So over here, this would be the opposite side. Side A would be my adjacent side, and side C is my hypotenuse side. So I'm going to start with side A. So if I'm going to use this angle, I want to use the angle I know and the side that I know. So I got an angle, I'm dealing with an opposite, and I want to solve for an adjacent side. So opposite and adjacent, opposite and adjacent. From our trig functions, that is a tangent. So if I take a tangent of this angle, 37 degrees, I should get opposite over adjacent, or 11 divided by side A. Now, here's one reason why we can't use the calculator here. Or sorry, here's one reason why we can't use the table there. Is we're going to try and find tangent of 37 degrees. And if you look at the front, we only found tangent of 30 degrees, 45, and 60. So I can't exactly use that table, so I'm going to have to use a calculator. So thank goodness, I mean, we could do a lot of different things in here, but our calculators also, they have a sine, cosine, and tangent. Now, in order to make sure you get a right answer, you want to make sure your calculator is in the right mode. So if you do mode, make sure you're set to degrees and not radians, because we're dealing with tangent of 37 degrees. So make sure you have that. So I'm going to start by finding the tangent of 37 degrees, and I get 0.7535540501. Now here's the reason why what we did on the other side of this paper is a lot more exact, because at this point, I might round this number one way, you might round it a different way, while another student rounds it a different way. So we all get relatively close answers, but depending on our rounding, we might all be a little bit different. So I'm going to use, let's do 7.54. So I have 0.754 equals 11 over A. Now to solve this, I got to get A all by itself. A is currently located in the denominator. I kind of want to get that out of the denominator so I can more easily get it isolated. So if I'm dividing by A, we can easily just multiply this side by A while multiplying that side by A. And if you do that, those will cancel. So we're left with 11. And on the left side, we have an a times a 0.754. So fractions are gone. This makes it a lot easier to solve. So the only thing left to do is divide by 0.754, divide by 0.754, and that will get our a all alone. And then on the meantime, on the other side, 0.754 divided by, other way, 11 divided by 0.754, we get 14 point, with my rounding, 14.59. So again, with depending on your rounding, each of us might get slightly different answers there. So that's why the calculator approach is a little bit not as precise. So we have 14.59. So all we have to do is solve for our last side. Again, let's use what we were given. Use that we know for sure is correct. So I'm dealing with an angle, I'm dealing with an opposite side, and I'm dealing with a hypotenuse. So the trig function that uses an opposite and a hypotenuse, that is sine. So we're going to have sine of 37 equals 11 over c. And you're going to find that the process of solving this c is very, very similar to what I just did, except I'm using sine instead of tangent. So I'm going to start by doing sine of 37, 0.60181. We'll call that 0.602. See how that rounding can get very interesting. To get c by itself, I need to get it out of the denominator, so I'm going to multiply it by c, multiply it by c. So I have c times 0.602 equals 11. Then divide by 0.602, divide by 0.602. And we're going to find that this side c is going to be 18.27. So that is solving a triangle using our trig functions. A few things is I would stick, when you're dealing with, only use what you can use, which is given to you. And also stick to your basic three trig functions, sine, cosine, and tangent. We don't have a cosecant, secant, and cotangent button in there. We can do it in the calculator, but I like to keep things basic, so that is the best approach there. And that was solving for sides and angles using trig functions.